Sorry for the delay, I was late this morning. So I will talk about the global burnt area from the ESA Fire CCI initiative. So I'm not, so the leader of this is in the Chuvieco, so I did not process everything. So I was more involved in the synthesis of available products and their uncertainty. And the work which was done here was used for the to identify the user needs and the targets for the Fire CCI project. Most of the information is on the website here, and so I will present here the effort we did in identifying the needs, and I will present a few slides about the results we just got last week for this project. So basically, the scientific context about this goal, the goal of this task was to get burnt area at the global level. Why do we need that? Is because at the global level we have 300 to 450 million hectares burnt every year, and that fires significantly contribute to CO2 emission and other trace gases to the atmosphere. So basically, if we go back the last few years, the global burnt area was first investigated by Howell Lee in 1994 with basically just an empirical estimate of burnt area only through fire return intervals in the dominant biomes of the world. Then FAO provided some compilation of national fire statistics with differences of available data between the countries, and early end of the 90s and early 2000 we started to get continental to global scale data from remote sensing. So from the year 2000 onwards we could see the emergence of global burnt area products, and I listed here the main available data used now for modeling or fire risk analysis. So the most famous one is GFED, of course. So I showed here GFED number 3, but number 4 is now available. So this one is from MODIS and TRIM data sets in ATSR, and the resolution is 0.5 degrees on the monthly time step. Other available data are mostly the MODIS MCD45 products, starting from the year 2000 onwards, at 500 meter resolution on a monthly basis. And other products came from the European Space Agency with other sensors like spot vegetation and ATSR, mostly. And the GBS dataset covered the period 92 to 99, but at 8 kilometer resolution from the AHR datasets. So basically, that's the picture of what are the available data from the year 2000. So in a recent paper here, we analyzed the historical use of all these products in the scientific literature. So we could see here that from the year 2000 onwards, we have an increasing use of these data sets. All the data sets are used, and there is an increasing, actually an increasing use of GFED and MODIS compared to the other data sets. We also have an increasing use of fire activity data sets, which are different from burnt area, as they are only the active fire from both MODIS and ATSR. And here again, MODIS is the mostly used data set in the literature. So from this, we also analyzed for which research topics these data sets were used. And at the beginning, basically, the idea was to build this data set at a global level to get to insert this data into air chemistry model and carbon models. Actually, we can figure that since the year 2000, we have only a third of the papers published which are actually dedicated to this, and we have an increasing number of users using these data sets for forestry or ecosystem and fire risk analysis. So basically the needs, the initial needs from the air chemistry community might have changed across time because many users are come from another community than this air chemistry domain. If we also look at the domain of application, if it's global or continental or regional, we can see that there is a huge decrease of global application of the products that they were built for, and an increasing use for continental or even regional assessment of burnt areas. So this is mainly in the tropics, where actually no fire data exists from national statistics. So the only data available to characterize a fire regime, in a national park or whatever, are these information. That's not the case in Europe or US or Canada, where we have actually fire data from fire statistics with fire shapes and everything. So, from this observation of change in user needs and the dominance of the use of MODIS data, we try to learn the lessons from the comparison of the many papers who look at the comparison between actual data from ground observation and the other products. So I just cited like three main papers who in this paper there was a comparison between either MODIS, ATSR, or A3GRC or other global projects and ground observation. So on the left one, it's the comparison between European countries' fire statistics with the global products. In the second one, this is the comparison between GFED and 2 and 3 and the observation in South Africa, and no, in the US and Canada, sorry. And on the right one, this is the comparison between the global products and Landsat observation for South Africa. So in most of the cases, actually, the conclusion are that MODIS and GFED are the most reliable data compared to ground observations. When we look at the comparison between all these products for different biomes, like savannas, like boreal or temperate forests, or savannas or tropics, we can see that basically if we take GFED3 as the reference, we have actually an overestimation of most of the products compared to these reference data sets. So now if we try to figure what was the requirements for future products from the lessons learned from this historical use of global data sets, and we analyzed the different global projects for developing global data sets, and there were needs, particular requirements for the spatial resolution, mainly to decrease down to 200 and 500 meter resolution, and then increasing demand for eventually daily data sets or weekly data sets. And of course, there was a target to get accuracy with commission and omission errors around 5%. That was the main goal to get for all this project. And another additional information would be, at least if we don't get an accurate data set, at least to quantify the error related to these data sets. We also performed, so this was the analysis of publications and reports for fire products, and we also sent a questionnaire to users to get their needs, and we try to send this questionnaire to as many field of research as possible, like, not only air chemistry but also ecosystem and forest managers. So basically, what we got here is that, of course, the main concern was that the spatial location of actual fires with minimum omission and commission errors, and the threshold of 5 to 10% was considered for most of the users. And there was a concern about the timing of the fire, and here the request can be down to 1 day, like when people for air chemistry, for example, who wants really to know which day the fire emission occurs. So there is according to resolution, there is an increasing demand according to resolution from the left, which is the 1 degree resolution, to the right, which is the 500 meter resolution. There is an increasing demand for high resolution data sets. And we also figured some targets to get from these users, and particularly among others requests, we had, of course, the date of burn detection. That would be with an error of plus or minus 2 days. And also we got the request to get the dominant vegetation cover affected by the detected fires. So these were 2 main goals that we figured as essential for the community, for this project. So here now, what has been done in the ESA fire CCI initiatives. So this is described basically in the product specification documents released on the website. So the ESA fire CCI is a product with a merging of 3 sensors: the ATSR, vegetation, spot vegetation, and marine satellites. And basically, this is the same approach as the GFED approach, which use different sensors to get the most accurate information. And the spatial resolution would be at the end 1,000 meter, 1 kilometer, and up to 300 meter only when marine information is available. So the target objectives were to get at least 90% of the actual burned area, and the errors target was around 15%, and the resolution of 1 kilometer. And the target accuracy in the date of burning was ±3 days. The ESA fire SSAI product has 2 levels of data: the pixel level, so at 1 kilometer or 300 meter resolution. And this is GeoTIFF data sets with 4 layers. The first layer gives you the date of the fire detection, which is the day of the year. The second information is the sensor which detected the burned area on a given pixel. So the code is from 0 to 15 or something like that, depending on the aggregation of the different sensors. For example, 1 is only ATSR, 2 is only spot vegetation, and you have the combination of all the sensors available in this second layer. The third layer is the confidence level. So for a given pixel, how much are we confident in that the fire, the burned area is actually detected? So it's a value between 0 and 100, 100 being the best information. And layer 4 gives you the land cover type. For now, this is from the land cover 2005 information. So it gives you a number between 0 and n being all the land cover types in the globe cover information. The second level of available data is the 0.5 degree resolution data at the global level. So here you have 22 information. The four first one first information is the burn area, of course. The second one is the standard error, the error associated with the burn area provided. The third information is actually the fraction of observed area depending on the cloud cover and other problems in the initial satellite images. And the fourth information is a quantification of the number of burnt patches within the grid cell. Then you have the layer 6 to 22, which gives you the burnt area per the vegetation type from the globe cover 2005 information. So you have how much, so within the total burnt area, you have how much is distributed in each vegetation type. So I just want to finish with some early results. So we got, for now, the years 2006, 7, and 8 have been processed, and we just got the information like 2 weeks ago. So this is a first comparison between the ESA Fire CCI for the 3 years with the GV4 data set, which is also newly released information from GFED, so the last version. And basically, if we plot the ratio of ESA compared to GFED, we have the results that the ESA products give you around twice more burnt area than the GFED 4 and 3 data set. So basically, this is distributed globally, except some areas like Southern Africa, where ESA Fire CCI describes less burnt area than the GFED actually. So one of the reasons of this, when we look more closely at the data sets, and we look not only at the difference in burnt area, but where the difference exists between GFED and ESA, we have here the burnt area from ESA outside of the GFED map, where GFED doesn't detect pixels. So we have here that ESA detects many burnt area outside of the usually observed burnt area from GFED. And we can hypothesize here that most of these fires are actually small fires from the agricultural burning. So we have part of it. Part of the explanation of this overestimation of ESA is that they detect more small fires, and they detect also fires outside of the usual range of GV4. So is that accurate or not? We are still trying to figure this, but from the Van der Velde paper in 2010, we could already figure that actually the agricultural fires were actually underestimated in GFED datasets. So we might think that additional information from ESA could be actually very good to get accurate information at the global level. I will end this talk with an additional data set which could be useful for the community, which is the fire long-term reconstruction from National and Territorial Statistics. So this is based on a paper I published back in 2005, which was a historical reconstruction of burnt area from statistics for the 20th century, which has been used in other papers to reconstruct the fire history before the satellite era. And there was a problem that the burnt area produced in this paper was not matching the GFED data. So we are now processing this historical data set to get a match between the ESA fire dataset and this fire statistic to get to reconstruct backwards a fire history and give a side product of the ESA CCI remote sensing product. Thank you.
Thank you very much. The floor is open again. There is a question there.
Sergey Vinesky. The question, you talk about wonderful burnt area products, but from the point of view of model, fire model, you also need to have an intensity, fire intensity, which is important to translate the spicy emissions. Do you work on this question?
Yeah, yes, actually, that's another that was a request actually from the community. But for the products released from now, there is no information on the burning intensity. available from this project.
Any other questions? Yes, one there.
Thanks. The issue with agricultural burning is a tricky one. So the fires are fairly short-lived, and the field size distribution varies considerably. So how do you go about validating your agricultural burning?
The validation on agricultural burning, there are validation data sets for this project, which includes grasslands and agricultural land. So they could be validated on these sites, but at the global level, agricultural burning is still not really well known beside the knowledge of agricultural practice according to the country. So we might have a best guess, but getting accurate information on to validate precisely data sets might be tough.
Any other question? So let me ask a quick one, maybe we can talk later on. In this statistical analysis, did you find any trend for each site throughout time? Or did you find laws like resilience, or that you could explain resilience and all the concepts that fire ecologists are invested in to understand patterns and the loss of fire?
You talk about
the last one, that you, for each site you are doing this statistical analysis of tens, temporal tens.
No.
So what was the conclusion of this work?
Temporal trends. No, I mean, you mean for this long-term information? Oh, these are based on, so this is not related to the fire remote sensing project. We have only 3 years. Okay. But now from the, from this historical construction, they are very reliable for since the 60s for the northern hemisphere. They are not reliable for the tropics. So we have a trend in fire increase in some areas since the 60s, but for savannas or tropics, we don't have information beside the crop road.
Very interesting. We'll talk later.
Yeah.
Thank you very much. We have now the last talk on global biomass mapping.